the value, that is the cost matrix, is given to you, and the different suppliers and the destination is given. But now we are doing the method is LCM method, that is the least cost method, right? Least cost method of solving your transportation problem with the finding out the initial feasible solution. Like we have given a different supplier S1, S2 and S3, right? Start writing now. And we have given a different destination, that we can be a warehouse, D1, D2, D3 and D4, right? And the values, that is the cost metric for supplying S1 to D1, it is 8, this is 6 and 10, 9, right? And over here, that means when from S2 to D2, if I'm talking about D1, first is 9, 12, 13 and 7. And then transferring from S3 to different destination is 14, 9, 16 and 5. This information is given to you as per the case study. Further, you have given the capacity, right? What is the capacity? There's the supply capacity of that supplier is 20. We have given 20, we have given 30 and 25, right? This is the supply capacity, and we have the requirement. What is the requirement or the demand for that? It is 15 over here for the D1. Then we have the 25. Then we have 20, and then last we have the 50. So first we start up the same category. How we'll start up? First we find out whether the demand and supply are equal or not. If it is not equal, definitely we have to create a dummy rows and column. So find out total of supply units. That means how much units is required, supplied, and total of demand. Total of supply, that is capacity, that is 20 plus 30 plus 25. That will be equals to 75. Coming up with the next one, that is your demand, or we can say it as a requirement. 15 plus 25 plus 20 plus 50. And then again it will be equals to 75. That means where demand and supply are equal, there is no need to create a dummy rows and columns. Now we were doing this method by the least cost method. So in the least cost method, what we have to do? We have to find out the least cost cell from all the rows and columns. Right? From all the rows and the columns, we have to find out the least cost value. So write the question again, like here it is S1, S2, S3. Yes, we can do in that matrix also, but it will look cool that you have to do it in the different matrix. And the one more thing we can do up, like we can reduce the matrix into the different matrix so that it will be more neat and clean. It's up to you. You can do in one matrix also, or otherwise you can reduce it. In this question, I will try to make it in the reduced way. Okay. So it can be a good presentation to you. Like 8, 6, 10, 9, it is given to you. 9, 12, 13, write down 9, 12, 13 and 7. In the next we have given a 14, 9, 16 and 5, right? This is the matrix, cost matrix we have given up. And again we have given the supply, that is the capacity, that is 20, 30 and 25, right? Over here we given a demand, that is 15, 25, 20 and 50, right? The least cost method, again, what you can do up, you can reduce the matrix or you can do it in the same matrix only. That doesn't matter a lot. So focus on the least cost value. Find out the most least one from all the matrix. Consider all the matrix and find the least cost value. So the least cost value from all the matrix or from all the cells is come to be at 5. So we'll give the allocation to 5 as much as we can. That means 15 or 25, how much allocation we can do up? The maximum, that is the lowest of these two, that will be a 15. That means we have given a 15 allocation, so it will be 0 and remaining over will be 10. This is one thing that we have given the allocation as G4 is wind up. So what we'll do, we will delete D4, or what we do, we can reduce the matrix. We can write the reduced matrix over here, and reduced matrix will be D1, D2, D3. This can be done up or in this way also done up. So I'm doing this way only, like reducing this matrix. So we deleted this one, right? Now we have to find out the least pending from all the remaining points. So all the remaining point is the 8 is the least one. Yes, 8 is the least one. So I give the allocation to 8 as much as like 15 over here. Demand, that is the requirement of this is D1, but the supply is 20. So yes, but we can give it as it is required maximum 15 units. So we given a 15 units. So the remaining balance will be 0. And here remaining balance will be 5. Right. So this allocation is again done up. That is allocation done. Right. Now we have the pending destination is D2, D3. So we have to find out the least value from these values. But before starting up further, there is a mistake. If I have a look from this one, from 5, the least value after 5 we came to know is 6 rather than 8. So we're just erasing this part which we have done up right now. This part we have to erase up because this is not the correct one. We have to give the allocation to 6 first of all, rather than we give an allocation to 8. So coming up with the next step, that is the first allocation we give to 6, the next least value, and this will be 20, right? So 20 allocation is done over here to make it 0, and the remaining point over here will be 5, right? So this allocation is done up, so we delete this. How much we have done up? 20 is done up, so this will be again deleted, right? Now we have to find out the least one. Now the point over here is the least one is 9 over here and 9 over here. So ma'am, which one we should select it? See, there is no situation arises like if we take that one, D1 will be the answer will be changed, but we try to give the one who is having the maximum allocation so that the least cost will be feasible for you. So the maximum allocation in D1, if I'm talking about D1, then we can give the maximum allocation over here to 15, right? So we'll try in that way only. We give maximum allocation over here is 15, right? And this pending value will be 15, the remaining one. So we can find it that we have allocated all the values to D1. So delete that column, right? And the remaining over here is also 0. Now coming up again, the next feasible point that the least cost point is 9 only over here. And we give that best part is 5 and the remaining part over 10 minus 5, that is 5. But D2 requirement is all done, 20 and 5, that will be 0. So we're done with the D2 also. Now find out the least in D3, that is 13 and 16. So how much we will give it? First we give it to the 13 because it is the more least part. And for 13, that is for S2 D3, how much we can give it? We can give it only 15. Yes, and this will be 0. And from 20, as we have given 15, so remaining part is only 5. When it is remaining part, last allocation is there. Yes, it will be 5 only. Now again it is 0, and this value is also 0. From this, we can find out that all the allocations been done up and the last remaining value is 0 in this scenario. So now we will calculate the total feasible solution, right? Now we have to give the answer as a total feasible or total initial feasible solution. That is initial feasible solution, okay? Total initial feasible solution in this case is equals to how much is feasible solution is there from S1. Now your goods from S1 to D2. First, that is your S1, and from S1, how much units we have transferred? 20 units we have transferred at a rate of rupees 6. So S1 to D2 is how much? S1 to D2 is 20 units. Right, so write it over here, 20 units at a rate of rupees 6. So 20 units multiplied by 6, that will be 120 rupees. Like, so the total transportation cost over here is 120 rupees. Now coming up to the next case, that how much we have transferred from S2. Like S2, how much units we have transferred to S1? S2 to D1, how much units? That is 15 units at a rate of rupees 9. So write it over here, 15 units, right? And the cost for 1 unit is rupees 9. So 15 units multiplied by rupees 9, right? Then it will be rupees 135. Rupees 135 is your answer, right? Now coming up with the next point, that is S2 to D3. Yes, the units are being transferred from S2 to D3, right? D1 is done up, D2 is not there, D3 is 15 units. So S2 to D3 is equals to how much units is there? 15 units, and the 15 units will be transferred at a rate of rupees 13. At a rate of rupees 13, that will be equal to rupees 195, right? Now again from S3, check it from S3, we are transferring to D2. S3 to D2, how much units is there? We transfer 5 units at a rate of rupees 9. So 5 units multiplied by at a rate of rupees 9, that will be rupees 45, right? So S3 to D2 is also be done. Now from S3 to D3, that is 5 units at a rate of rupees 16, right? 5 rupees at a rate of rupees 16. Now this is the last unit, second last unit, S3 to D3 is equals to how much units are there? 5 units, and that units multiplied by at a rate of rupees 16, that will be equal to rupees 80, right? Now coming up last, that is S3 to D4, the last unit from S3 to D4. How many units are being transferred from S3? Then again 5 units at a rate of rupees 5 units at a rate of rupees 5 only. So 5 units multiplied by how much units? At a rate of rupees 5 rupees. That means rupees 25. 15 rupees or 5 rupees? It's last unit we just had checked once again. How many units are there? In the last 15 units, sorry, it is 15 units. Please check it, 15 units at a rate of rupees 5. So write it over here as 15 units. That is 15 units at a rate of rupees 5. So it will be 75, right? So make it correct as that 75 over here. So done it over here as a 75. Now take a calculator with you and add all the values together. 120 plus 135 plus 195 plus 45 plus 80, and the last one is your 75. Add on all these figures and you will get the answer of 650 rupees. That means with the least cost method, same questions which we have done from the northwest corner, but from this part we calculated and we get the answer of 650 rupees. That can be possible that the same scenario is there, but the answer is different. But these are all initial feasible solution. But for getting the optimum solution, yes, definitely we will apply the Modi method and find it whether the initial feasible solution remains the same as the feasible solution, this one, or the optimum solution. So this is the way you calculated your LCM method, right? Now we will do the next very important method, that is called as the WAM method. As we use all these methods, all the methods have their own like merits and demerits, and you using weapon depending upon the business of the scenario, how the business is going on and how the work is going on, and which method gives you the best scenario. So we'll try to use all the method. We should learn all the methods and apply as the situation arises. From the academic, like from the test point of view, yes, this is the most important method, WAM method, vowel approximation method. That is the most important method. Most of the time this paper comes up and they specially signify you that I need the answer of transportation from Vogel's approximation method. Yes, from the Vogel's approximation method also we are able to find out the initial feasible solution, and after the Vogel's approximation method we used to apply the WAM method, right? So starting up with this question with the Vogel's approximation method, start down. Like first we have to write down the factory that we are given up. Like we are taking in this example, we have given a 3 factory where the manufacturing is going on. Take example S1, or where the supplier is sitting and they transfer the goods from these 3 areas. So we have given 3, S1, S2 and S3. We have write it down over here, as well as we given as the different warehouses where the suppliers transfer their goods to the different warehouses, and we have taken 1, 2, 3, 4. W1, W2, W3, and W4. These are the four warehouses which is given to us. And for every warehouses, yes, there is a capacity requirement as well as their demand requirement. So note down all the values that it is capacity, right? And that is your requirement, that is the demand one. So writing the demand part also here, right? And the cost matrix, yes, it is given. So writing down all the values, 19, 30. For W3, it is 50 and then 10. And for W4, it is 10. It is 70, then again 30, again 40, and it is 60. And for S3, it is 40, and it is 8, and the last W3 it is 70, and the last one is 20. Right, these are the values, that is the cost matrix which is given in the question as per the scenario. Now what we have to find out, from which supplier to which warehouse we have to transfer the goods, so that we get the best initial solution, and your initial feasible solution is the optimum one, that will be also be checked out, right? You are given the capacity, and the capacity note over here is 7, over here is 9, and the last one is 18, right? 7, 9, 18, and the demand requirement is also given, that is 5, 8, 7, and 14. So this is the demand requirement. So first again we have to find out, yes, we have to find out whether the total demand and supplies are equal or not. So start adding the total demand and supply, 7 plus 9 plus 18, and for the requirement it is given 5 plus 8 plus 7 plus 14. So check it whether both the values are equal or not. Yes, both the values are equal to 34. Right, so note down over here total of this point is same whether you are going for the northwest corner, or either you're going to go for the VAM method or the least cost method. Total of supply you have to find it, and the total of demand you have to find it. Yes, this both the values should be come up equal. Otherwise, the question will be of unbalanced, and then you have to create a dummy balance. Then only you have to proceed further for the methods and for calculating the initial feasible solution. What happens if you are not checking the total demand and supply? And similarly, you initially started off without adding the values, and after that you came to know, oh, the question is of unbalanced, then your all the question, your all the answer will be all tampered out, right? So adding all the supply values, that is 7 plus 9 plus 18, right? That will be equals to 34. And same with the demand, adding all the values of demand, that is 5 plus 8 plus 7 and plus 14. Adding these all values also 34. This indicates that demand and supply are equal. Now what happened in the VAM method? We used to calculate the penalty cost. How this penalty cost will work up? It indicates that if you are not transferring the goods from direct supply to the which one is the more requirement warehouse, that means you are not using your mind effectively and efficiently, you are bearing an extra cost. So first we have to find out the extra cost, and for this in the VAM method we have given the name of extra cost as a name of penalty cost. That is, and how this penalty cost is calculated? This penalty cost is calculated by taking the difference of the two lowest cell value of each row, right? From each row we have to find out the two lowest value, subtract that it, and then write it over there. So first penalty we have to write it over here as the P1 for calculating the penalty. So I'm writing over here as P1 first penalty. The lowest of the value is 10 in the first row. Okay, check it on the first row, that is 10 and 19. So the difference between 10 and 19 is 9. So we write it over as 9. Right. Same with the S2. Find out the two lowest value, that is 30 and 40. Then we have to find the penalty, that is 10. Right. Same with the S3. The lowest value, that is 8 and 20. That will be 12. So we write it over here as 12. So we find out the penalty one for one row, right? For the first scenario. Now again we have to find it over here also. Yes, we have to calculate the penalty row wise also as well as the column wise. Now in the first column, that is W1, we find out the least value, that is 70 and 40. The difference between the 70 and the 40, the lowest value, sorry, we have to take, and that is 19 and 40. So the 19 and 14 difference will be 21. So write it over here as 21, right? Same with W2, that the lowest value is 8 and 30, then the difference value will be 22. Write it over there. With W3, that is the difference between the lowest value 40 and 50, that is 10. So write it over here. And for W4, that is 10 and 20. So write it over here as 10. Right? This is the first step. How we calculate the penalty? Taking the two lowest or the least value and subtracting that least value. Right? And then subtracting that least value. After calculating the penalty from each rows and column, then find out the maximum penalty. So from here, the maximum penalty is, and give the allocation to that cell. 9, 10, 12, 10, 10, and 22 and 21. So the maximum value is in W2. So select the W2 and give the maximum allocation of the lowest one. So the lowest one is 8, and how much allocation we can do in this cell is like 22. What is the requirement of this is 8, and what is the capacity we can, it is 18. So maximum how much we can give, 8. So the balance value remaining after giving the 8 will be 0 over here. And for 18, when we give the allocation 18, that's when the pending one will be 10. Hope you getting. So this W2 is wind up as we have given the maximum allocation to this. You can do the reframe the matrix, or you can do in this only and delete this W2 as the maximum capacity requirement of W2 requirement is done. Right? Now repeat this process again. Yes, you have to repeat this process. No need to worry, we will do more practice, but just you have to repeat the same steps again and again. What? Find the least cost value. Then the least cost value is 10 and 19. That will be again 9 over here. Right. Then from this 40 and 60, then will be 20 over here. Right. And 20 and 40, then the least cost value will be 20 in the S3 cell. Right. 40, because 8 is now no over there, 40 and 20. So 20 minus 40, that will be 20. Same over here in the column wise and the row wise, again we have to calculate. So calculate the P2 over here. Difference between the two lowest value, that will remain same, that is 21 over here. There will be no penalty because already W2 is deleted. So no value has to be write down in the W2, right? So 0 value. And for W3, we have to find out. And what will be the W3 value? Lowest, that is 40 and 50. That will be 10 value, right? So write it over here as 10, right? And over W4, again 10 and 20. So write the same value, that is 10. This is the P2 penalty. Same scenario, we have to find out the maximum one. Now the maximum allocation which we can do in this is the 9, 20, 20, and this is 10, 10, and now this is from here it is like 21 is the maximum. So on which allocation we will go on? 21, because it is the maximum over here. Okay, so we select the unit of 21. Give the allocation with the same color I am selecting. Yes, it is selected. From the W1, the maximum we selected us, and the lowest one we have to select. Lowest is 19. Give the allocation to this is 5, because it is 5 and 7. The maximum allocation we can give is 5. So the value remaining over here will be 0, and from 7 we have given 5. The remaining value will be 2, right? Now our W1 is also wind up. So what we have to do, select the W1 and delete it, because all the penalties will be, all the allocations has been done, right? Now the same process goes on till all the allocations is over. Now coming up further, yes, you have to calculate P3 now, and the penalty 3, as W1 is also wind up, so we have to select the least cost, that is 50 and 10 over here. So it will be 40, right? 40 and 60, that the difference will be 20 in this scenario, and 70 and 20, that will be 50, right? Over to P3 also we have to find out. So I'm writing over here P3, that is again no more, that is again no more. And in W3 we can find out, and the W3 is how much? 50, 40, 70, that is 50 and 40 will take it and the value will come up is 10, and over here also 10 and 20, then the value will come up 10. Hope you're getting this way how we find out the value. This is 40, bacha. Okay. How the 40? The difference between 50 and 10. We calculated the 3 penalties. Kindly check it. Are you able to find out all these penalties? How we find out the penalties? The difference between the two least cost in each row and column. Differentiate between them, and from all the penalties we have to find out the maximum one. So in this case the maximum one is 50. Now you have to give the allocation to S3, and the lowest one we will select. The lowest one is 20. Give the allocation from this cell first of all. How much allocation we can give up? This is 14, this is 10. So the maximum allocation we can give is 10, right? So here it will be 0 as we have given all the allocation, but from 14 we have given 10, so remaining one is 4 over here, right? Now the remaining pending is 4 over here. Now you have to check it, which one is remaining and which one is pending. We can do like we can find out from another one, like again we have to find out the yes. You can find it the penalty also of, in this case, like S3 is wind up, so you have deleted S3. Now the remaining box is 50, 10, 40 and 60. You can find out the least one, or again you can give for the penalty, but we can find it, ma'am. This is now the 10 is the lowest, so we can select the 10. Yes, otherwise, you can find the maximum penalty P4 and you find it, yes, the maximum is coming over there only. Right. So how will we give the maximum allocation? Or otherwise, what you can do up, you can also find out the, like, give the allocation, start selecting the penalty. Next penalty also you can find out, like you can find it P4. The difference again 50 and 40, that is 50 and 10, that is 40, and 40 and 60, that is 20, right? So maximum allocation you have to find out, and the maximum per person and the maximum how much candidates is there to whom you can give the allocation. So what we find it over here, the maximum allocation. Remember the pending over here is in the one S1 is 2, in S2 it is 9 pending over here, right? The balance is still going on. So what we do, the maximum allocation we can do up, but over here we will start the allocation and it is allocation will be 2, right? The maximum W4 allocation can be done up is 2. Remaining, because the requirement is 4, but their capacity is 2, so we will give 2 only, right? So the capacity pending with the S1 will be 0, right? So make it over here as 0, and the remaining requirement, that will again it will be 2, right? Because 4 we have given up, 2 is pending. Now S1 is now deleted because it's all allocation being done. Now the pending one is only 40 and 60. So the least one over here is 40 first of all. From 40, how much you can give the allocation? 7 is pending. So you are giving 7 over here. And the remaining over here, 9 out of 7 you have given. 2 balance is pending with this 2. And this 7 is also being wind up, that is 0. So the maximum remaining pending allocation over here is 2, and the balance over here is also 0, and the balance over the last one, that is W4, is also 0. So this way all the allocations being done up. Now you have to check all the allocations being done up, all the values are been 0. Yes, all the values are 0, all the allocations being done up. Now what your last process is, now you have to find out the total initial feasible solution in the same scenario, multiply by the units with their cost price. Like from S1 to S3, how much units are being transferred up and how much cost is there. From S1 to W1, like from here you can have a look, from S1 to W1, 19 into 5 units is there. So what we will do, 19 multiplied by 5. From S1 to W4, how much units being transferred? 10 into 2, that is 20. From S2 to W3, that is 40 into 7, 7 for the 28. From S2 to W4, 60 into 2, and so on. With this process, we will find out the total initial feasible solution. And the total initial feasible solution in this came up 779 rupees. So this is your total initial feasible solution with the help of Vogel's approximation method, right? This is the way we can do the BAM method. There are multiple ways, like you can do up like reducing the new matrix, preparing the new matrix again. Again, you can give the penalty in the new matrix, then reducing that penalty and give the matrix to the that one.